Today we are going to talk all about maps because we are mad about maps. This is instead of fun with flags for you Big Bang Theory fans out there. So here we go. All right, so globes versus maps. So globes are pretty easy. They're the Earth. They're a 3D scale model of the Earth. They show accurate area, accurate distance, and direction, and even the Great Circle route, which we'll talk about in just a second. The issue is they lack detail, okay, because they are not. You can't zoom them in enough to get an accurate representation of what the Earth is like. So that's why we have maps. So maps are two-dimensional. So they're a symbolic representation of the Earth. They're much greater detail because, once again, you can zoom in on them. But the biggest issue with maps is because they're two-dimensional, they're always going to be distorted in some way. So they're either distorted with area, with distance, direction, the Great Circle route, which I'm about to explain here in just a second. So all of that is an issue with maps, okay? So the biggest issue is distortion. So getting into the Great Circle route, and obviously that's one I want you to highlight. On maps, the Great Circle route will look like this, okay? So it looks like on the maps of the planes, I'll show you one in just a second, it looks like the plane is going up and the plane is going down. Well, that's not what's going on. This right here looks like a straight line, but it's not really. So this actually is a straight line. Okay, it doesn't look like a straight line because the curvature of the Earth keeps it from being like that. So this is not a straight line. This is actually it actually goes south more out of the way because this looks like it's the right direction, but this is actually the true direction. Okay, this is the actual straight line, and that just shows you the distortion of the maps on there. So this right here is a map of different flights, and you can see when I was a kid, I used to always think that these maps were the plane going up and the plane going down, but that's not how it is. But you could see the farther away it is, the greater the curvature it is. So these we're going out of Vancouver here. The flights going, to other places in Canada look a lot more straight than the flight going all the way to London or Amsterdam, okay, or Seoul or Beijing, okay, and that's because of the curvature of the Earth. Okay, map projections. So map projections, there's all kinds of different types of map projections, depending on what you want to see in regard to the Earth. And so a map projection is a process of representing the rounded Earth on a flat surface. So like I said, distance, shape, direction, all that may be and is distorted in some way. But the purpose of the map usually dictates which projection will be used. So there are three main types of projection. So you have the planar, the cylindrical, and the conic. Okay, planar is also sometimes called azimuthal. So the cylindrical map, we're going to take a look at these in a second and what they actually look like. Okay, but the cylindrical map looks like this: the conical and the azimuthal, or the planar. And then there's two types of different maps that you can create with these projections. So you can create an interrupted map or an uninterrupted map. And so we'll take a look at some of these in just a moment here. Okay, so this right here shows the different types of maps. So you have the cylindrical map, looks like this. So it basically, if you take a cylinder and you look all the way around the map and flatten that out, what would that look like? Okay, this right here is a conical map. Okay, so this is what it would actually look like. And then this is the planar or the azimuthal, and it just shows within a plane, if you're looking at the Earth just straight, what does that look like? Okay, so let's take a look at some specific map projections. Oh, I'm sorry. So this is an uninterrupted map would look like this. An interrupted map would look like this. Okay, so these are the different types of maps. Okay, so The first one we're going to look at is probably a very familiar map to you. This is called the Mercator projection. The Mercator, I want you to go and highlight each of these names of these projections. I realize I didn't put them in red like I had intended. So make sure you highlight each of the names because I'm going to give you pictures and then I'm going to have you identify which map it is. But the Mercator projection is a cylindrical projection. It's the most common one that you probably have seen. It's often used by sailors because the grid of the map is very easy to read. Because it is easy to determine latitude and longitude on there. However, the land is distorted. So, for example, if you look at Greenland here, Greenland looks much bigger than Africa. Well, the problem is Africa is actually 14 times bigger than Greenland. Okay, Antarctica looks much bigger than it actually is. So the land, especially towards the poles, is much more distorted and elongated. Okay, so that's the Mercator projection. Make sure you highlight that, please. The next one, another very common one, is called the Winkel triple. Okay, so this was developed by a German, his last name was Winkel, in the 1920s. And it's basically the globe. Okay, it's a projection of the globe. So you could see, I'm going to show you another map that's going to look really similar to this. But you can see the lines of latitude and the lines of longitude are all distorted. So it gives it a little better look land-wise. You can see like Greenland is not bigger than Africa anymore. So it's a little, land-wise, it's a little closer to accurate. Okay. And then the next one is going to look similar, but it's a little bit different, and I'll show you how you can tell the difference. So this is called the Robinson projection, and this is another one that shows the whole world. Now Robinson, this was created, I think, in the 50s, but he was looking at it more artistically. He wanted to show the world more artistically. So if you look at this, the lines of latitude are actually really straight, where the lines of longitude are curved. So the only exception to this is obviously the prime meridian and the equator. Now in the Winkel triple, it's just the prime meridian. Well, the prime meridian and the equator are not are flat. Okay, on this one, all the lines of latitude, so including the equator, are flat. So that's the biggest difference. Is the Robinson doesn't take into account the latitude moving away from the equator. Okay, so that's the biggest difference, but it does show land more accurately than, say, the Mercator does. Next projection is called Goody-Homolcene, and this is an interrupted map. So this one, the landforms are almost exactly accurate. But obviously the oceans are interrupted. So this is a tough one to actually use. Interrupted maps will show things a little more accurately, but it's harder to use them. Okay, so the oceans are more distorted, and it's difficult to see how much distance is between, like, Hawaii's over here and Chile's over here. What is the distance there? It's difficult to do that. Okay, so that's a harder one to use. But if you're looking at just landforms, this is a pretty accurate one. And then this one is the orthograph. So this one was created in the 90s by a Japanese engineer. He won a big prize for this. And basically what he did was he took a globe and basically put each little part of it into triangles. And then he put those triangles together to create this map projection. So this is the most accurate map projection to where you can put this exactly on a globe and it will be pretty accurate. But you could see it's really difficult to use. You can see like the lines of latitude and longitude are all over the place. And even like Brazil looks a little bit weird on this, and Africa's a little bit distorted. So it's difficult to use and it's difficult to read. But this is the closest to accurate that we have. Okay, so parts of a map. So on your paper, what I want you to do is and this is why your notes are in slides this time, is I want you to go and I want you to insert shapes just as I do showing the different parts of the map. Now, the first one, the map frame, I don't necessarily want you to do like I do where it covers the map. I'll show you in just a second. Just do like a transparent one in the middle, okay? So the map frame is the meat of the map, okay? So it's everything that's inside this. Okay, so everything inside that is considered the map frame. It is the object of the map. Okay, the next element we're going to look at is a locator. So oftentimes maps will have a locator where it shows you exactly where this is. So this is obviously a very zoomed in version of a map. And so you can see on that it is just that part right there. Now an inset would be this, okay, or the one down here, where it's something more specifically zoomed in to show it, okay? So you got Anegada and then St. Croix are right there, and then they're zoomed in, okay? So you could take a better look at them. So that's the difference between the locator is showing on the earth where this map is, and then the inset is zooming in more specifically on a specific part of the map. Okay, every map has a title, or should have a title, so you know what you're looking at. Usually it'll tell you exactly what this is. So we're looking at the Virgin Island coral reef creatures. Maps usually have a legend or sometimes a key. Okay, so it shows you what the different symbols are and what they mean. Okay. They will often have a scale bar, so you can see that on the bottom right there. A scale bar will show you how far. Usually they use like an inch or whatever the scale is to show, like in this case, about 4 miles is probably an inch if we're looking at this at the size that it's supposed to be. And then north arrow or compass rose. In this case, this is a compass rose. Sometimes they'll just have an arrow pointing north. That's just so you can see which direction everything is going in. It's not always, not every map shows north at the top. Kind of depends on what the map is looking at. So you have to make sure you're paying attention to that. The next one is a citation. So a citation just gives you some information about where they got this information. It'll give you information about basically like who funded it and the purpose for it. And the next thing is a border. Okay, so that's this all around it, okay, is the border. So this over here, this is the border, and this right here is the neat line. Okay, so the neat line shows there's a neat line here that shows how it's separated, so it just kind of helps to organize the map and make it look nicer. Okay, that's it. That's all I got about maps, so hopefully you learned a little something. There's no processor with this one. I was hoping the processor was going to be to do a map, but this parts of a map is pretty much what the processor was going to be. So I hope you all have a wonderful day, and I'll see you guys later.